Hi, good morning to everyone. This is me Saima Khadim from Daud University of Engineering and Technology, Sindh, Pakistan, working as a lab engineer in Department of Telecommunication Engineering and also a master's student of Telecommunication Engineering. Before to start my presentation, I am very thankful to all the sponsors and organizers of the conference to give me opportunity to present my papers in third international conference on green computing and engineering technologies. Today I am going to present on a survey on cognitive radio network using artificial intelligence. These are the contents of my presentation. Introduction. As the spectrum scarcity has increased, dynamic spectrum access is considered to be a vital element of future communication. Spectrum can be divided into white spaces, black spaces, and gray spaces. Unlike static spectrum access, dynamic spectrum access can considerably solve the issue of imbalance in spectrum utilization. Cognitive radio defines the use of both unlicensed user and licensed user for dynamically spectrum accessing. Cognitive radio make the decision by sensing the both outer environment as well as internal parameters. Federal Communication Commission defines high throughput, minimum interference, and interoperability as operating parameters of cognitive radio. We have seen that IEEE 802.11 standard utilizing the television white spaces for wireless regional area networks. As the need for higher bandwidth will increase and simultaneously number of wireless devices arises, so the importance of cognitive radio will also increase. Cognitive radio has the ability to improve capacity and spectrum access. The cognition, that is learning and reasoning ability of cognitive radio, is provided through a number of ways. But one of the most popular way of providing this cognition is implementing machine learning techniques. Cognitive radio can be used in various applications like spectrum market, grid communication, public safety, femtocell, self-organizing networks. These machine learning techniques enable the cognitive engine to make accurate decisions, saving time and power and making the system more reliable. Artificial neural network is one of the most widely used machine learning technique for cognitive radio. We will discuss how artificial neural networks support cognitive radio, its comparison with other machine learning techniques, and several algorithms proposed by various authors that improve the performance of artificial neural network. Artificial neural network. Artificial neural network are computational tools inspired by brain's working of neurons. The idea was first presented by the neurophysiologist W. Muchello and the logician W. Pitts in 1943. Artificial neural networks are provided with input and output data, then they are trained mapping input to the output target. The neurons are arranged in three layers: input layer, output layer, and the hidden layers. Artificial neurons get input from all neighboring neurons and then adjust itself depending on weight and activation function. Each neuron produces its single output value by accumulating input from other neurons. Learning of artificial neural network is achieved till the difference between the required output and output of network is negligible. Artificial neural network is a nonlinear function with flexible parameters to give required output. Artificial neural network has the ability to learn different patterns, features, and attributes. By learning, the neurons' output are systematically adjusted and they can give result for new condition or data sets. Artificial neural network has been used in spectrum sensing for cognitive radio. Different training methods and configuration types of artificial neural network. Few types of artificial neural network with cognitive radio are as under. Number 1, multi-layer perceptron neural network. It consists of layer of neurons connected to previous layers, output in linear combination. The weights are randomly chosen and then adjusted to give accurate results. For adjusting weights, methods like genetic algorithm or backpropagation can be used. Number 2, Neural perceptron network. By introducing nonlinearity in the network, we can make the network adapt the sample test. This can be achieved by cross multiplying two inputs or squaring inputs. However, for training, weights backpropagation can make the network slow by increasing processing time. Radial basis function network. Perceptron network have the problem of settling into local minimal. This problem is resolved in RBF, which has a distance criteria with respect to center in its hidden layer. Its radical nonlinear function, which can be Gaussian, Euclidean, or any other. For training, gradient descent method is used. Cognitive radio and artificial neural network studies have shown that certain parts of a spectrum are overutilized while others are underutilized. In case if primary user does not use a band of frequencies in certain region or time period, it creates a spectrum hole, and cognitive radio exploits this availability by using it as secondary user. In reference summary 21, I can define the two main objectives of cognitive radio are efficient utilization of the spectrum and ensuring reliable communication. In reference number 23 and 24 defines a cognitive engine with its cognitive core performing all the learning and reasoning tasks. Cognitive radio should be equipped with learning and reasoning ability. This learning and reasoning requires artificial intelligence techniques. Various artificial intelligence techniques include neural network, fuzzy logic, hidden Markov model, and genetic algorithm. Through cognitive radio techniques of dynamic spectrum sharing are developed for efficiently using crowding frequency bands. In recent years, research has been done on applying machine learning techniques on cognitive radios. Machine learning techniques model. These are some papers which I have read. A network, a neural network-based spectrum prediction scheme for cognitive radio, and their authors are Vamsi Krishna, Timuliro, Pingwang, and Dusit Niato, which is published in 2010. In this paper, author used the MLP algorithm for spectrum prediction, which improves the spectrum utilization and reduces sensing energy. Next one is learning-based primary user activity prediction in cognitive radio network for efficient dynamic spectrum access. And their authors are Anirudh Agarwal, Shivangi Dubey, Muhammad Asif Khan, Ranjan Gangopade, and Sumitra, which is published in 2016. In this paper, to provide a longest ideal time of a new spectrum to the unlicensed user by using machine learning technique. Four supervised machine learning techniques are used, two from artificial intelligence and two from support vector machine. Next paper is channel state prediction in a cognitive radio network using neural network Levenberg-Marguerite algorithm. And the authors are Pavitra Roy and Dr. Muralidhar, which is published in 2015. In this paper, to predict the ideal slots in the channel which is based on the past information, and then allow CR to select best slot for data transmission. For ideal slot prediction, neural network Levenberg-Marguerite algorithm is used. Next paper is performance evaluation of neural network based spectrum sensing in cognitive radio, and their authors are Rahul Singh and Sarita Kansal, which is published in 2016. The goal is to increase the decision accuracy in the presence of noise in the environment for secondary user by using neural network based spectrum sensing. Neural network is an intelligent or smart technique to predict the unused spectrum. Next paper is channel status prediction for cognitive radio network, and their authors are Vamsi Krishna, Timuliro, Pingwang, and Dusit Niato, which is published in 2010. In this paper, two techniques, multi-layer perceptron and hidden Markov model, are used for spectrum prediction. The advantage of the channel predictor is that these do not require any prior knowledge of the channel. Compare the accuracy of multi-layer perceptron and hidden Markov model. Next paper is artificial neural network based spectrum recognition in cognitive radio, and the authors are Rahul Singh and Sarita Kansal, which is published in 2016. The basic purpose is to increase the decision accuracy under the various different noisy conditions, and it have implemented by using multi-layer perceptron neural network. Next one is contextual neural network based spectrum prediction for cognitive radio, and their authors are Masih Jolanta Mazira, which is published in 2015. Contextual sigma if neural network is used to predict the status of channel or spectrum status for cognitive radio. From the simulation results, it is concluded that the contextual sigma if algorithm is slightly better than multi-layer perceptron neural network for prediction, and also it reduces the sensing time for prediction. Next paper is comparing performance of multi-layer perceptron and RBF neural network for TV ideal channel prediction cognitive radio, and their authors are Onch Winston, Fulo Thomas, and William Ukello, which is published in 2013. In this paper, author compared the performance of two most popular neural network algorithms, multi-layer perceptron neural network and radial basis function neural network. The mean square error value of MLP is 0.06666 and the mean square value of RBF is 0.0835026. And from the simulation results, author concluded that the MLP is slightly better than RBF. Conclusion: by artificial intelligence, we can achieve our goal of spectrum prediction, which is vital for cognitive engine. Among various machine learning techniques, artificial neural network stand out of the most useful technique as it does not require much prior knowledge of the system to make decision. Implementing of ANN adds complexity in the system, but by certain modification in the artificial neural network system make it more accurate. Perceptron neural network is more accurate than Elman or feed-forward neural network. Its accuracy is also higher than of RBF or other popular machine learning technique like hidden Markov model. While neural network Levenberg algorithm perform even better than perceptron neural network. These are the reference of the paper. Thank you.